Hello guys, welcome back to our last topic dedicated to sequence. It's topic sequence 4, method of difference, or what is known the difference method for the sequence. Alright, so for those who haven't seen the previous videos, all 3 parts in the previous videos, I strongly recommend to go back and just check them out. So for those who actually watched and probably solve several exercises dedicated to sequence and now have a little experience in that, just let's try to figure out how method of difference works. All right, so let's assume we have an arithmetic sequence given with the formula 3n plus 1. All right, we know that this sort of sequence is arithmetic because in the previous videos we actually did and derived several formulas dedicated to it. So the general formula is u1 plus n minus 1 times d. So because u1 and d are numbers, we can simplify and go to linear form of dependency, un's term from n. So basically it has the high resemblance, and actually it is, with a linear function. Remember, for linear function, let's say argument is x in this case, we saw, for example, for straight lines, how f function depending on x value. And it depends in the following manner, mx plus c. Alright, so m and c coefficients. Alright, that's the high resemblance, right? And actually it is. So that's what is called linear formula for the sequence. In this case, it's applicable to only arithmetic sequence. So linear formula for the sequence. All right. So looks like for the sequence that we can generate using the formula several terms. For that, we can apply this general form, yeah, because it matched to it. So in this case, A is 3 and B is 1. If you just compare coefficients here and here. All right. So let's construct the table where we can generate several terms of the sequence. Let's say n runs from 1 to 4 and we fix several terms. All right. So we can use the formula. So it's 4, the first term is 4, so we plug then 7, so we know the difference is 3, and now we can just figure out more easily, so just 10, 13. All right, so we know for this particular sequence, it will generate elements from 4 to 13. All right, now let's pretend that we don't know the formula. Let's say we have no idea how it looks like. But we know because it's arithmetic sequence. So because it's arithmetic sequence, we're pretty sure that general form un from n will have this linear formula n plus b. And our goal is to find coefficient a and b in order to have a proper formula for our sequence. All right, so let's find out how to do. In this case, I will exactly apply the method of difference and methods of differences. So, and exactly in a few minutes, you'll actually understand how it works. All right, so we know the values, right, for any given number. We know several values, all right, and we want to establish values for A and B. How we can do that? So straight away, we can plug the following numbers, 1, 2, let's say 3, into the formula, and we will have several equations set up in order to find A and B. All right, so if you remember simultaneous equation topic, you know that if we have two unknowns, in this case, it's a and b, so we need to set up two equations, all right? So we need to set up two equations. Okay, that means we can just plug only two numbers instead of n. And that will give us two equations for nth term. So, okay, you would say that we want to plug n equals 1 into the formula. We'll find u1, all right? So u1 becomes a plus b because n goes instead of n in the formula, all right? So on n equals 1, we plug it and we'll get a plus b. All right, so that will generate the first term. Okay, when n equals 2, we'll get u second term, all right? Let's do it. 2a plus b. Okay, and instead of u2 and u1, we can pick up values from here because we know that u1 is 4 and u2 is 7. Okay, so we can plug instead of u1 and u2 corresponding values. All right, so what we'll have? We'll have 4 equals a plus b and u2 7 equals 2a plus b. All right, so what do we have? We have two equations. All right, there are two ways to go. First, the first way is just normally solve as simultaneous equations, all right? Just you set up two equations, a plus b equals 4 and 2a plus b equals 7. And you solve them like standard linear equations. Okay, how to figure out values? So you can use method of substitution, or you just directly subtract from, let's say, second equation, you subtract 1. Why? Because it will kill your b. Okay, so let's use that. Subtract 2 minus 1, and you'll get 2a plus b minus a plus b. So on the right side, you need to subtract from 7, 4. Okay, so, and actually, b will be cancelled. So you live with a equals 3. Okay, we find out that a is 3, and if you go back a little, so we know that a is coefficient before n, so in this case a is 3. So we should get b equals 1. All right, let's see. So having a to be 3, we just plug, let's say, in the first equation, and we'll get 3 plus b equals 4, from where 4 minus 3 is 1. All right, we got both values. As you can see, method of difference actually works like simultaneous equation, but actually, why it's called method of difference? All right, if you can do using simultaneous equations. All right, and I'll give you an explanation here. As I told you that we can do in two ways. The first, it was about solving or considering as simultaneous equation, but there is the second way. So what you can do if you know that this is u1 and this is u2, you can subtract, right? You can have difference u2 minus u1, all right? So that should give you a difference for arithmetic sequence. And as you remember, it's constant, it's not changing. All right, in our case, difference is 3. So we can say that u2 minus u1 should give you a value of 3. Okay, but we know, actually from here, 7 minus 4 is also 3. That matches the case. And if we subtract 2a plus b and we subtract a plus b, we'll get the following: 2a plus b, that's u2, u subtracting u1, that is a plus b, and you should get the difference. In our case, difference is 3, and as you remember, b were cancelled, So 2a minus a is a. Alright, so you'll get that a, leading coefficient, is exactly the difference, alright? So that's why this method is called method of difference. So you immediately can figure out that leading coefficient should be difference, alright? So how to find b? Okay, easily. You can plug 3 back here, alright? So in this equation, you plug a equals 3, and you clearly see that b is 4 minus a, 4 minus 3, it's 1, alright? So, but a key idea is here that if you subtract two adjacent terms, you'll arrive to the difference. If you write each term through general equation, so you'll get a coefficient. So, okay, one more time, in order to maybe recap what we need to do. So, if we have linear dependency, i.e. arithmetic sequence, we need to plug n equals 1, n equals 2 in the general formula for n's term, because we're looking at n's term in this way, and we will complete two equations set up for u1 and for u2. Okay, so because you know the value for u1 and u2, you know it's 4 and 7 correspondingly, you can express as the following: 4 equals a plus b and 7 equals 2a plus b. Okay, and how to solve it? So you can solve either through simultaneous equations. That's normally how you're solving two equations with two unknowns. Or you can apply the short way. This is the short path. Know that if you subtract u2 and u1, you'll get the difference. That's why this method is called method of difference. You subtracting 2a plus b, that's actually u2, and you subtracting u1, and that's how you arrive to the difference. So it everywhere, for any arithmetic sequence, your leading coefficient should be equal to difference. All right, and how you figure out b? Okay, you just plug into any equation you like. So I prefer the first one because some small coefficients, it's easier. So you plug back a equals 3 and you figure out the value for b. All right, that's how it works. And this is very necessary for understanding in order to get to like more complicated sequence where you apply the same method of difference. For example, for quadratic one or even for cubic one. So you need to understand this logic. So I think in the next video we'll move on to quadratic formula for the sequence and cubic one. So we just consider both of them as more like, complicated case. But, for IGCSE and GCSE stuff, for examination, for a successful passing exams, you need to know method of difference, because in every single past paper, you'll definitely meet that, right? And in future papers, you'll definitely meet that. All right, so hope you enjoy and see the track for the last sequence for method difference applicable to nonlinear sequences, quadratic and cubic ones. Okay, so look forward. Goodbye.